it says graph the lines represented by these equations. So what we're going to do is we're going to start with the first one. 2x plus y equals 2. What's the easiest way to graph a line? Who remembers? What's the easiest way to graph a line? Yeah, Davey? Yes, that's it exactly. So let's subtract that 2x from both sides. B is 2. That's your y-intercept. And my slope, we're going to make it negative 2 over 1. So the fastest way to graph a line is when it is easily y equals mx plus b. So we're going to go plot the y-intercept of 2, and then you go down to right 1, down to right 1, down to right 1. Then you can follow the pattern going up. I like to put dots all the way on my grid. And you do put arrows on the ends because the line does continue forever in both directions. All right, then let's look at this next one. This is y minus 4 equals negative 2x plus 6. This is y equals negative 2x plus 10. All right, my graph is going to go off the chart a little bit, so let's just guesstimate. So you're just going to, I'm sorry about that. Hi.
Hi, I'm here to take the test for ID 12.
Oh, yeah, that's right.
Thank you. Yeah, that works so much. Thank you.
Okay. There. Thanks, Carolyn. Appreciate it. All right. So, what do we notice? Do you know what do you notice about the slopes and the intercepts? Say it again. I couldn't hear you. Okay, the lines are parallel. Okay, the lines are parallel. The lines have the same slope, but different y-intercepts. And really, that's the definition of parallel lines. Two lines that never intersect. They have the same slope and different y-intercepts. All right, in linear modeling, back in Algebra 1, you looked at slope-intercept form, y equals mx plus b, and point slope. So let's use a highlighter. These are two really, really important formulas that you're supposed to remember. Y minus y1 equals m times the quantity x minus x1. Except for vertical lines, all lines are graphs of functions. We're going to do an investigation that will help you see the effect that moving the graph of a line has on its equation. Moving a graph horizontally or vertically is called a translation. The discoveries you make about translations of lines will apply to those family of functions. The x squared, the x cubed, the square root, the cube root. It applies to everything, even the 1 over x. Okay, so everything we're learning, it's going to apply. So we're going to do a little investigation together. Graph the line y equals 2x. Well, the slope is 2. And what's the y-intercept? 0. So you're going to plot 0, and then you go up 2, right 1, up 2, right 1, up 2, right 1, and so on. A little bit off there. Okay, now it says we want to draw a line that's parallel to this, but 3 units higher. How would we do that? Yeah, Davey? Yeah, exactly. We're going to go up 3, but then it has the same slope, right? Up 2, right 1, up 2, right 1. What's the equation of this new line? Yeah, Angelo? All right, nice. So when you want to take a line and you want to move it up or down, what's changing is the y-intercept. The slope remains the same. So how would I describe this in terms of f of x? Well, I would say this. Do you see this is f of x, and we've just added 3 to it. Step 2. We want to graph another line on the same grid, but we want to move it 4 units lower. How would you graph this if I want it 4 units lower? Yeah, Keelan? Nice job. Y equals 2x minus 4. And on the grid, you're just going to go down 1, 2, 3, 4, and then do a slope of 2. In terms of f of x, see, f of x is y. So it was 2x, and then we subtracted 4. All right, now step 3. So, and we're doing this still on the same graph. We're still on the investigation. Mark a point where the graph, so the graph is at the origin, right? And then now we want to move one that's 3 to the right. So I'm going to pick a new color. 1, 2, 3 to the right, but then it's going to have the same slope. So I want to kind of talk about this one. So I have a new point, 3, 0, and the slope is 2. Now I want us to use point slope form, and hopefully that's coming back to you from Algebra 1 that you did point slope. Let's plug in the point and the m value. So that's y minus 0 equals 2 times the quantity x minus 3. So the 0 just goes away. And here's the equation. Now, this one I think is the trickiest part. You remember our composition of functions. This is like a beautiful connection here. Do you see that my x, okay, this x right here, can you guys look here? You see where my little flashing cursor's going? Do you see this x? Remember our composition of functions? I have replaced the x with x minus 3. Okay, I have replaced the x with x minus 3. So watch how we can rewrite this. This is f of x minus 3. Now I want to go back to the graph because this is like the one tricky part of this. My purple line is 3 units to the right, isn't it? My purple line is 3 units to the right, but the equation has x minus 3. So when you move it to the right, it's x minus the number, okay? So for me, I try to think of it's the opposite of what I think, left, right, and it's the same up, down. So it's kind of weird. All right, so in step 4, plot a point 1 unit left and 2 units up. 1 left and 2 up. So let me go back here, and I'm going to go 1 left. Let me change colors so we can see it. Let's do orange. 1 left and 2 up. Oh, isn't that already on a line that we drew? Isn't it already there? So watch this. So I now have a point. I went 1 left and up 2. And the slope was still 2. Yeah. It's not on the line for you? Oh, okay. I think did I draw one of mine off? My blue line wrong? It's not on your up 3? Oh. I went up 2, right 1, up 2, right 1. Oh, yeah, you're right. Okay, so it's not on the line. That's fine. Thank you, though. Okay, so watch what I'm going to do. I'm going to use this point slope to write the equation of this line. You're right, it is a distinct line. Thank you. So that's y minus 2 equals 2 times x. What happens when you do minus a negative? It becomes a positive. So then it says write this now in terms of f of x. So this is going to go y minus 2 equals f of x plus 1. Because what I've done is I've replaced the x with an x plus 1. And then I could add the 2 to both sides. So here's kind of the big idea. This is where now when we're putting it together it can be confusing. I moved up 2, so there's a plus 2 on the outside. But when I went left 1, because it's x minus a negative, it does the opposite of what you think, and it's x plus 1. Okay? So in step 5, if you move every point of y equals f of x to a new point, up k units and right h units, what is the equation? In general, it's y equals f of x minus h plus k. So it's going to be the opposite of what you think on the inside, the same as what you think on the outside. The k does the up-down, the h does the left-right, but the opposite of what you think. So I'm going to go nice and slowly here. I'm going to go back through before we move on. Because I want you to understand, like, if we take these notes and the notes don't make sense, then they're not helpful to us. So let me go back up here. Do you remember how I said, let's move the point to right 3 units? But when we moved it right 3 units, that was x minus 3. So right 3 did x minus 3. So it did the opposite of what you think. But when we did this, when we went down 4, it was minus 4. So that's what I'm talking about, okay? So it's a little bit confusing. And then once we get the hang of it, it's very, very straightforward. So if you know the effects of translations, translations are left, right, up, down shifts, you can write an equation that translates any function on a graph, no matter what the shape of a function. So if I say I have, then y equals f of x minus 3 plus 2 will look the exact same. Whoops. Not sure what happened there. Did you guys have any internet? Yeah, I think because I have to record via Zoom here. Yay, you are connected. Yay, there we are. All right, so I'm right here. So do you see what I have in purple? That means I am right 3 units up 2. But think about that family of functions packet. It doesn't matter if it's x squared, x cubed, 1 over x. That notation works universally, which is so cool. So in my box, we're going to go over this again. If you have y equals f of x minus h plus k, or I'm going to stick with the second one. I think that might help. It's going to be horizontally means left or right h units and up and down k units. So if you have difficulty remembering it, you can take a point, do the shifts, and then put it back into the function. So let's look at example A. Describe how this has been shifted. So do you see, here's my 2 and there's my 2. So anybody want to tackle this? And we could even, whoops, rewrite it like this if this helps. So what does the 4 do? It goes up 4. And what about that x minus 3? What shift is that? It'll be right 3. There you go. All right, let's look at example B. Okay, look at example B. The one that's in black, y equals f of x, that's the original. The red one is how it got shifted. So what I like to do is I just pick one point and figure out how it got moved. So let's say we do this one right here. Do you see this one? This is at 1, 1. Where did it get moved? 1, 2, would it be 3, negative 2? Yeah. Okay, so let's pause a moment here. And we just picked a point. We're going to call it this one right here. We have 1, 1. And it's getting shifted 3, negative 2. So can somebody describe the translations? How have the points been moved? Okay, right, how many? Right 2. And down how many? 3. All right, so then here's how we describe it. Right 2 is going to go f of x minus 2 and down 3. So just remember that this is just going to take a little bit of getting used to. The inside is really the opposite. It goes x minus 2 in the function because then it's going to do the opposite in the actual equations. All right, you can describe or graph a transformation of a function graph without knowing the equation. But in the next few lessons, you will find that knowledge of equations for different families of functions can help you learn more about transformations. This is why we did what we did with that family of functions packet. All right, we have something called mapping notation. One tool that we will use frequently in our study of function transformations is a mapping function. This is a way of describing a particular transformation mathematically. A mapping is a multivariable function to describe the transformation's effects on the x and y variables between the parent and child functions. All right, so t of x gets mapped into a function of x, comma, the function of y. So what you do, and if you look at this box right here, you replace x by x minus h and y by y minus k, and it ends up being a translation of xy goes to x plus h, y plus k. So let's look at the extra examples. If I have the graph of the line y equals negative 2x minus 1, that's been translated is translated 2 units horizontally and 6 units vertically. Write an equation of the new line. So you replace the x, it's x minus negative 2, and it's up 6. So this would be y equals negative 2 times x plus 2 plus 6. Oh, whoops, I lost the minus 1, didn't I? Sorry, there was a minus 1 here. Sorry. So then that ends up being plus 5. So you replace the x with x minus the shift. And then do you see there what I missed that little 1 right here? This was right here. All right, in number 2, rewrite y equals f of x as a function that has been translated 3 units vertically and 4 horizontally. So minus 3 means down 3. 4 means right 4. So now there's a difference between the equation and the function notation. Okay, there's a difference here. So now I want to take this. This will be f of x minus 4 minus 3. So do you see the difference between problem 1 and problem 2? Problem 1, I'm just replacing x with x minus and then the plus k. And then when you do the function notation, it's x minus that h value. All right, in the closing question, how might you rewrite y equals 3x minus 6 to show that the equation can show a vertical and horizontal translation of the line with equation y equals 3x? Well, do you see I could factor out the 3. So this would show right 2 units. Or I could take this equation and wouldn't this one, just how it is, show it's down 6 units? All right, that finishes our notes